Okay, this is 8.2, systems of linear equations in three variables. Okay, so an equation such as this, we have an x, y, and z. It's called a linear equation with three variables. You can take a moment and read this. Okay, so we're talking about x, y, and z, so we can arrange our planes in three different ways. We know how to arrange the planes of x, y, but when we start talking about x, y, z, we're typically going to use this one. This one allows us to see things in three dimensions. Okay, so show that the order triple 102 is a solution of this system. Now, what does 102 mean? Well, we can think of a system of three equations as x, y, z. So in order to show that this works, all we have to do is plug in 1, 0, and 2 to their respective values and check that it works. So when I plug it in, I get 1 minus 0 plus 2. Does that equal 3? Yep. Then I have 2 plus 0 minus 10. Does that equal negative 8? Yep. And then I have 1 minus 0 plus 6. Does that equal 7? It does. So that means that this is a solution of the system because it works for all three. Okay, solving linear systems in three variables by eliminating variables. Basically, what we're trying to do here is we're trying to reduce our three equations of three variables to two equations with two variables because we know how to use that. We know how to do that. So once we do that, we can solve it like a traditional system. Okay, so let's go ahead and solve the system here. So what I do is I label my equations 1, 2, and 3. So I'm going to label this 1, 2, and 3. And I'm going to use them by their names, and we're going to kind of figure out what to do. Well, as I'm looking at this, I can see here that this has a plus c and this has a minus c. So if I add these two together, we know that we're going to be able to cancel that out. So I'm going to have 1 plus 2. So let's go ahead and write that out next to it. So 5x minus 3y plus z equals 2, and 2x minus y minus z equals negative 3. So now all I'm going to do is just add straight down, and so that's going to allow us to see that the z's are canceling, and what we're left with is 7x minus 4y, and that equals negative 1. That's awesome. That means that we already have one of our equations. But now what we need to do is we need to use another two equations to reduce it down and to get an equation with just x's and y's. So in this case, I'm going to use 2 and 3. Now in order for me to cancel out these z's, I need to have this one have a 5 in front, which means that I need to do 5 times 2 plus 3, and that should be able to cancel out those z's. So if I do 5 times 2, I get 10x minus 5y minus 5z, and that equals negative 15. You cannot forget to multiply it by this guy over on this side. And then we're having 3, so 3 just stays the same. And now all I have to do is add them up. I see that my z's cancel, which is what I needed. So I'm left with 11x minus 7y, and that equals negative 3. Well, this is awesome. Now I have a new system of equation. I have 7x minus 4y, and that equals negative 1, and then 11x minus 7y, and that equals negative 3. So I'm going to go ahead and label this guy 4 and this guy 5. So now I need to cancel something, and so I decide that I'm going to cancel the y's. I could choose to cancel the x's, but I'm going to cancel the y's instead. So I know that I need to make that top equation have 28y and the bottom equation have 28y. So I'm going to make the top one positive. Why not? So I'm going to do negative 7 times my equation 4, and then a positive 4 times the equation of 5. So as I go through, you get negative 49x plus 28y equals 7. And then when I multiply the 4, I have 44x minus 28y, and that equals negative 12. And now all I have to do is add them up. I see that my y's cancel, and so I'm left with a negative 5x, and that equals a negative 5. So x has to equal 1. That's awesome. We already know one variable, so now we have to do it just like normal. Now we go back and plug in to one of our equations over here that has just x and y and solve for y. So to do that, I can say, okay, I'm just going to use the top one. So 7 times 1 minus 4y equals negative 1. Well, that's 7 minus 4y equals negative 1, minus 4y equals negative 8. Y is equal to 2. Awesome. Now I have 2 of my 3 variables. Now I go back up here to my original and pick one of those. So it doesn't matter which one you choose. I'm going to choose this one right here. So when we do that, we see, okay, so I'm going to choose the second one. So I now plug in 2 times 1 minus 2 minus z equals negative 3. Well, that's 2 minus 2 minus z equals negative 3. Well, 2 minus 2, well, those go away. So I'm left with negative z equals negative 3, or that z is equal to 3. Now keep in mind, how do we write our answers? We write them in that weird ordered pair. So it's 1, comma, what's y? 2, comma, 3. This is our solution to that system of equations. Okay, why don't you take a few minutes, pause the video, and see if you can solve this systems of equations by yourself. So this is the solution that I got. I labeled my equations, went down 1, 2, and 3. I went ahead and reduced the first and third one in order for me to cancel out the y's, so I was left with an x and z equation. I did the same thing with equations 2 and 3, and I was left with another x-z equation. I used those two, canceled out the z's to be left with just x. So I had to go back from x into one of these equations. I solved for z. And then once I had x and z, I went back to one of these guys, plugged in, and found out what my y was. You might have canceled out different variables in a different order, but ultimately we're going to get the same answer of negative 1, 3, and 1. Okay, so this is asking us to write the equation of the parabola in this form that contains these points. Why don't you take a moment to see if you can think about how you would do that? How would you even start this? Well, in order to start it, what we would do is we would take our values here of 1 and 2, and I would plug in 1 for my x, and then 2 would go in for the y, and you're left with something that looks like this. When I plug in 3 for my y, and I plug in 2 for my x, well, I have 2 squared is 4, so that's 4a plus 2b plus c equals 3. And then I plug in 5 and negative 18, and I get negative 18 equals 25a plus 5b plus c. So this is a great way to kind of see how this works out. So why don't you take a minute and solve this system of equations and figure out what a, b, and c would be. Because once you find out what a, b, and c are, you know that you can just plug them in here, and then you have your equation. Okay, so here you can see that I labeled my 3 equations. I went ahead and saw that if I just subtracted 2, then I was able to change all my signs, and I was able to cancel out the c's. And once I got here, I saw that I had negative 1 equals negative 3a minus b, and I can actually reduce that. I can reduce that by dividing everything by a negative and just getting something that looks like this. Then I looked at 1 and 3, and I went ahead and just subtracted 3 from 1, and I got this equation down here. I saw that my c's went away. But again, I can reduce because I can see that 5 is equal to negative 6a minus b when I divide everything by 4. So now I have these 2 nice and easy equations that actually I don't have to do anything to. The b's, when I add them up, just go away, and I immediately have a. So I go back into one of them and I solve for b, and then I go back over here and I solved for c. So now that I have my a, b, and c, I have a, b, and c. I see that a was negative 2, b was positive 7, and c was negative 3. So there's the equation of the parabola. Okay, why don't you take a minute, read this problem, and then see if you can set up a systems of equations and then solve it. So this was the system that I came up with. I came up with that x plus y plus z was equal to 180. I had 2x plus 5 plus y equaled 180, and 2x minus 5 plus z equaled 180. Now, when I reduced that and kept it so it looked like our normal systems of equations, I saw that the first one had all the variables, the second one didn't have z, and the third one didn't have y. But I was able to get them so that all the numbers were on this side and all the variables were on this side. This is going to make it a little bit easier for us to solve it. So take a moment and see if you can solve it from here. Okay, so this is what I got. This is my system of equations right now. So I see that if I want to cancel out my z's, taking the first equation and subtracting the third equation gives me negative x plus y equals 5. Negative 5, excuse me. And I already know that I have this one right here, number 2, that already has x and y equals 175. So I don't have to do anything to that. That one immediately comes down right here. That's why it's still labeled as number 2. This guy moves over, and then I'm able to just subtract 4, cancel out my y's, and I get that x is equal to 60 degrees. So that's this guy right here. Then I go back in and I plug up here and solve for y, and so I get y to be 55, and then I get z to be 65 in that way. And if you add up 60, 65, and 55, you do in fact get 180 degrees. Just like if you were to plug them in here, that would be 180, and here would also be 180. All right, take a moment, read this, set up your system, solve it. All right, so as you can see here are my 3 equations right here. So I know that I have ticket prices, and I sold a total of 400 tickets. So over here to the right, you can see that I've labeled what X, Y, and Z stand for. I've added them up, and I get 400 tickets. I also know that 8 times the number of $8 tickets plus 10 times the number of $10 tickets and 12 times the number of $12 tickets yielded me $3,700. And then I know that the combined number of $8 and $10 tickets was 7 times the number of $12 tickets sold. So the combining of 8 and 12 is 7 times as many as 12. So when I make it equal 0, so I can have all the variables on one side and all the numbers on the other give me this. And then you can follow my math and see that we sell 200 $8 tickets, 150 $10 tickets, and 50 $12 tickets.